Hello, algebra people. Here is your video that is continuing the intro to functions videos, and it's going to be talking about domain and range from a graph. Now you can do domain and range without a graph, but it's easier with a graph, so we'll start with this. Now remember, a domain, you've talked about this probably in 8th grade, but it's going to be the set of all possible input values, which usually will be your x, and the range is all the output values, which is usually going to be your y. So for all these problems, I'll be giving you a graph, or you'll be given a graph in general, and you're going to be stating all the possible x's and y's that the graph takes on. So let's talk about two different ways to do this. For the first graph, I'll do a couple of these with you, and then I'll give you some to try. So why don't you put an ordered pair at 0, -3, and make the function curve up here, and dip down here. Don't worry too much about this. It goes down to the y value of 1, but don't stress about making that exact. So if you were in, let's say, 8th grade and you had to write the domain or range of this, you would probably use interval notation, meaning you would use inequality symbols, something like this, maybe with the equal bar under it. So let's try writing it like that, and then I'll show you a new notation that you're going to want to be practicing. So whenever you think about the domain, remember it's all the x's that are possible. So I'm on my x-axis here, and if you struggle with this at first, it's good to actually run your pen along the graph. Run the pen along the x-axis and then look up to the graph and see if it actually touches the graph there. So if I'm going along the x-axis here, I can see that anywhere I go along the x-axis, the graph maps to it. There's a y value that goes with it. And these arrows mean that the graph is going up forever and left forever. So that means if I keep going left forever, the graph is going to keep going. The graph's just not big enough to show that. Same over here. I'm going up and right forever. So I'm going to keep going here and keep going here. That means if I keep going left forever and ever and ever, I'm going to go down to -infinity. And if I keep going right forever and ever and ever, I'm going to go all the way up to positive infinity. And x is trapped in between those values. The smallest x can get is -infinity, the largest it can get is infinity. If I think about my y values, I'm running up and down the y-axis here, and you want to think, all right, does the graph go up forever? Does the graph go down forever? Now, looking at these arrows, it's pretty obvious that the graph does go up forever, meaning it goes all the way up to infinity, but it doesn't go down forever because along the y-axis here, the graph doesn't exist anywhere. The lowest possible place it can go is -3. Now, because this is a closed dot, that means the graph actually does take that y value on, so I need an equal bar there. I could not put an equal bar here, here, or here, because infinity is just a number. It's not an actual, an infinity is just an idea. Infinity is not a number. So you can never include infinity with an equal bar. Now this notation is okay, but I want you to move towards set notation, which is a slightly more advanced way of writing it. So set notation works like this. You're either going to use parentheses or you're going to use brackets. Parentheses means the number is not included. And brackets means the number is included. So make sure you jot this down so you remember, because this is probably going to be new for you. You can combine the parentheses and brackets in any way you want. So you can see things like this. It doesn't have to be the same on each end. And whenever you do it, you're always going to have a comma in the middle, and you're going to put the smallest number, comma, largest number, whether you have parentheses or brackets. So smallest number, comma, I'm out of room here, largest number. That's how you always set it up. You just put two things in here. So if I'm going to go back to here and I'm going to try and write this in set notation, I'm going to think, all right, the smallest value that x can take on is -infinity. The largest value x can take on is infinity. Now, like I said before, infinity is just an idea. So infinity will always use parentheses because you can't include a number that's just an idea. So it's going to look like that. If I'm going to try and do the same thing for y, the smallest y I take on is -3. The largest is infinity. Since I actually reach -3, I want to include that value. But since infinity is an idea, not a number, I'm not going to include it. All right, let's try another one. For this one, I want ordered pairs at -3, 0, 0, 3, and 3, 0. We're basically doing a semicircle here. So similar to the one before, I'm going to do domain and range in inequality notation, and then we'll try it in the set interval notation. Now set notation, this is also sometimes called interval notation. So just make sure if I say interval notation, you realize it's this new set notation you're learning. So let's think about our possible x's that we take on here. Now this graph only exists right here. So that means the graph is definitely not going to the right forever. In fact, the farthest right that this thing goes is at 3. Now at 3, let's try moving left. All these x's in the middle have y values that go with it. We're good, we're good, we're good, we're good, we're good. Over here, there's nothing. This is a dead zone. So the farthest left my x goes is -3. So that means -3. Now I'm including -3 and 3 because those are actual ordered pairs. This is my domain. My range, let's go up and down the y-axis like this. The furthest up that I can go while still covering the graph is here at 3. I can't go any further down than right here because down here, this is all dead zone. Nothing's going on down there. The furthest down I can go is 0. 3 is reached with a closed dot, so is 0. So I have 0 less than or equal to y less than or equal to 3. Let's convert these to set notation. I'm going to put smallest and largest. Both of these are achieved, which is why I had an equal bar. So I'm going to use brackets. Let's do the range. I go from 0 to 3. Both are equal bars because both values are included and reached. So that means, like right here we said included, I'm going to use brackets for both of them. Let me do one more with you and then I'll have you try a couple. I want you to go for the third one to the order pair -2, 5. So -2, 1, 2, 3, 4, 5. Put an open circle. And then let's have a graph that curves down and out like that. Now the open circle here is, remember, the graph does not reach this point, -2, 5. It goes all the way up to -2, 5. It gets to like -1.9999999, and it gets up to 4.9999999. But as soon as you get to -2, 5 right here, the graph does not include that point, which is why we put an open circle there. So just be aware of what open circle actually means. Let's do domain and range. So on the x-axis, I cannot go left forever here because I can see that none of this has a graph that goes with it. The furthest left that I can go while still including values of the graph is right here. I can go all the way to -2, except I can't include -2 because there's an open circle there. So now if I go right forever, let's follow this graph, right, 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 right. This arrow means we keep going right forever, all the way to infinity. I cannot include infinities, so don't do that. That's bad. We only put less than. You can't include an idea. For the range, let's see. We're going to go up and down the y-axis here. I definitely am not going up forever because this doesn't have any graph associated with it. The furthest up I can go is right here. Although I'm not actually reaching the y value here, which is 5, because there's an open circle. So I can get all the way up to 5, but not including it. The furthest down we can go, let's follow this thing down, 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 down. It's still going down and slowly down here, all the way down to negative infinity. Now don't put the 5 first, because we want to do the smallest y value, which is negative infinity, and then the largest y value. So, oh my God, what is going on here? So whatever, negative infinity, all the way up, that was weird, all the way up to 5. And I'm not including either of those because there was an open circle here and I can never include infinity. So time to do set or interval notation here. For the first one, I went from -2 to infinity. I cannot include infinity. I cannot include the -2 because there was an open circle right here. So I can go all the way up to -2, but I can't include it. Now some people ask, well, can't I do this? -1.9, comma, infinity. And can't I include -1.9? But then I would say, well, that means that you can't include -1.99, but you can. And then someone's like, well, isn't this okay? And then I'd be like, well, what about -1.999? Isn't that okay? And you can just keep going and going until eventually you'd probably have this bar, which means 1.99999 forever. And this just looks clunky and not very neat and efficient. So you don't want to write it like that. I mean, I know what you mean, but the best way is to let it go up to -2, but not include the next closest thing, which is really -1.9 repeating. This is just the superior way to write it. Okay. Oh, we forgot to do the y's. The y's would be -infinity to 5. Neither is included. All right, I'm going to give you one to try. Why don't you draw this graph? This graph is going to go up to 2, down to -2, up to 2, down to -2. Assume it does that forever. Sorry, this isn't the best graph I've ever drawn. It's repeating this over and over and over, left and right. So pause the video and try and do domain and range right there for the graph. Try doing interval and inequality notation. All right, you should be back now. Hopefully you realize that the y's go from -2 to 2. You never go below -2 or above 2, and you include those values, and the x's go on forever. All right, let's try this scatter plot looking graph here, which is not continuous because it's just really a scatter plot. It's discrete, remember? Discrete are individual sets of points that are not connected. All these other graphs were continuous when you drew them. This, however, is not continuous. Now, a very common mistake I see is this. Students think, all right, the smallest I can get is -3. And the largest I can get is 1, 2, 3, 4, 5, 6. And they want to do it like that for the x. And for the range, they want to go from 0 up to 3. This is bad, though. You don't want to do it like that because this means that every single x from -3 to 6 is hit. But that's just not true because all these spaces in here aren't hit. This x isn't hit. This x isn't hit, and all these fractions like 0.1, 0.2, 0.3, 0.4, 0.5, etc. Like none of those x's are hit. Only the individual ones that I graphed are hit. So you definitely don't want to do this. That's bad. The way that you have to do a discrete function is you're going to use these curly brackets, and you're going to list out all the individual values that are taken on. So for example, the domain, you go in order, and you order the numbers. So starting from the left, the furthest left value hit is -3. Then I get -2, I get -1. 0 is not hit, however, 1, 3, 1, 2, 3, 4, not 5, and 6 are hit. So you just list them out like that. For the range, that was terrible. For the range, you want to think, what are the y's that are reached? Well, these points have a y of 0. Now careful, you don't put 0 twice. You only put it once. 1 is reached 2 and 3 are reached. So you don't, no repeating numbers. Even if a number